Good afternoon, everyone. This is Batul from IGCP, the moderator for today's session, and I would like to welcome everyone wholeheartedly at our platform for the better exchange of knowledge that is going to be shared by our stalwart who is present here with us today. Now, without any further delay, I would like to welcome our stalwart, who is none other than a very renowned venerologist, Dr. Murugan Sankarantham sir. Sir is former professor in Department of Dermatology and Mineralogy at Sri Mokambika Institute of Medical Sciences, Kolasikaram, Kanyakumari District, Tamil Nadu. Sir is presently senior consultant in HIV and sexual medicine, Tirunelveli, Tamil Nadu, and former national president at Indian Association for the Study of Sexuality Transmitted Disease and AIDS. And the topic for today's discussion is the road of the goal of HIV cure. So now, without any further delay, I would like to welcome Sir at our forum and would like to hand over the session to him for his precious talk to begin. So over to you.
Thank you, Patul. Thank you, MedTalks and IJCP. And good afternoon, everybody. I am very much pleased to meet you all through this platform in this pleasant afternoon. And today the topic is HIV. HIV is a cure possible. That is the road to the goal of HIV cure. That is the topic of mine. Like HIV is an infection which is known to humankind for the past 4 decades only. Maybe there, it may be there previously, but we came to know only after 1980. One doctor, can I have the next slide, please? Dr. Michael Gottlieb, slide next, yes. Dr. Michael Gottlieb from United States. In 1980 and 81, some unprecedented infections and tumors which is not previously present in US hospitals was prevalent in certain hospitals like New York City and Los Angeles, especially in young homosexuals, and they were not able to find the real cause. All of them were having immune deficiency, cell-mediated immune deficiency. They were attributed this homosexual, mainly these people were having homosexual habits, so they attributed to homosexual activities, some sexual infection, or it may be due to some drugs used by them for their sexual activity like that. They were thinking. And can I have the next slide, please? And next slide, please. The HIV virus is a slow lentivirus, and this is a human immune deficiency virus, HIV 1 and 2, and this was first invented by, next slide, please, Luc Montagnier in France, Pasteur Institute, and subsequently within few months, Dr. Robert Gallo from Bethesda University. Can I have the next slide, please? Bethesda University, and they both found the same virus, but they named it as the Pasteur. That is, Luc Montagnier is named as a lymphadenopathy associated virus. Can I have the next slide, please? And Luc Montagnier named it as lymphadenopathy associated virus, whereas uh, Robert Gallo named it as human immunotrophic virus type 3. So in 1985 only they named it as HIV, and in 1987 we are able to find the first antiretroviral drug. Patul, can I have the next slide? Yes, next slide. So these are the two stalwarts, Luc Montagnier and Robert Gallo, who first discovered that virus in separate place, named it separately. In 1985, it has been named as HIV virus. Then 1987, the first antiretroviral drug, that is azithromycin, was found out. And next slide, please. The present status of HIV. HIV, once it was thought to be a killer disease till 1990s, and becomes a chronic, well manageable disease at present with the help of highly active antiretroviral drugs. But till date, it has to be, the patient has to, it's a chronic disease. No sterilizing cure was observed. Once the patient stopped the treatment, he may have once again flare up of the disease. And because of the heart, that is highly active antiretroviral drugs, antiviral therapy. The morbidity is less, mortality is less, almost coming down, and no total cure ensured so far. So that is the idea of this today's talk, whether we can achieve the total cure or not. Next slide, please. Why cure is necessary? Lifelong treatment is a burden for anybody. Daily taking drug without forgetting. So that is a imposition of a punishment. To have a normal life expectancy, we need total cure. To restore the immune function, our immune system back to normal, we need a total cure. To cut short the cost effect of the individual, family, and to the country, individual, family, and also for the previous slide, and also for the in that is nation, to reduce the morbidity I told already, to avoid exposing the drug toxicity forever. When the individual is taking any drug apart from B complex, water soluble B complex, anything has some side effects, some adverse effect, so we have to elude from that. So we have need a cure to avoid acceleration of aging process and other ill effects on the vital organs. So we need a cure. So is it possible? Next, next slide. Yes. What is a cure? So there is two types of cures available. One is functional cure, already what we are having, and another is sterilizing cure. Functional cure, that viral load virus is not detectable in blood circulation, but the HIV DNA can still be detected, indicating at any time it can replicate. Competent virus may be present in latent form in dormant tissue cells. So this is the reason the functional cure. We are achieving a total viral load suppression with the help of our existing anti-ART, but we are not able to achieve. We are not able to eliminate the latent reservoir of the replication competent viruses. Sterilizing cure is the one, there is no trace of residual disease there. Previous slide. That is, there will be no trace of residual disease in the body. Barrier cure is the latent reservoir persist barrier for the cure. Why we are not able to achieve the sterilizing cure? That is because of the latent reservoir persist for lifetime despite ART. That is, the ART can act in the circulation only. It cannot enter into the tissue reservoirs. So that is the reason. Next slide, please. Next slide, please. The persistence infection, latent CD4 cells present other than circulation, that is other than T4 lymphocytes, that can be CNS microglial cells, macrophages, monocytes, the peripheral mononuclear cells, reproductive system cells, lymph nodes, gut tissues. So in all these places, these CD4 receptors cells are available. So these virus may enter into that, and it will remain dormant. The ART can act only on the replication. It prevents the replication. It cannot kill the dormant virus. So inside the cell, that is the reason we are not able to achieve a cure. Next slide, please. So the ART, we are having different types of ART. They are working in various modes. So this is at the entry point, some drugs are preventing, and when the viral RNA enters into that, it converts into DNA, and the DNA enters into the nucleus. Once it enters into the nucleus, the disease becomes permanent, established, and after some time, these RNA released into the cytoplasm, once again converted into RNA and becomes a new virus. This is a cycle, and we are having various drugs to break the cycle. Entry inhibitors are there, and nucleus reverse inhibitors are there, non-nucleus reverse inhibitors. That is, RNA to DNA conversion is prevented, and the integrase inhibitor, it will prevent the entry into the nucleus. Protease inhibitors are there, and protease inhibitors prevents the formation of the newer viruses. We have to combine all one or two, three different sets. Then only it will be working well. There will not be any resistance. So this is the normal cycle. Next slide. Next slide, please. So ultimate goal of the present ART is we have to achieve a complete effective viral suppression. The viral load should be less than 400 copies after 24 weeks. When we start the correct combination and the viral drugs are effective, it will suppress below 400 after 24 weeks. And it will attain less than 50 copies within 48 weeks. So that is the possible present state. By achieving this less than 50 copies, we are achieving clinical, virological, and immunological cure. So this is the stage at which we are here. Now, next slide, please. So strategies for cure. We are having different strategies are there. We'll see one by one. It's a long procedure. Genetic, gene therapy, kick and kill method, immune-based method, early treatment. Genetic stem cell transplantation, thereby they have achieved few cures already. Gene therapy is under trial. Kick and kill method also I will explain. Immune-based also worked well in animals. Early treatment, what is early treatment? That's also possible. So all these things are various strategies for cure. Now, next slide, please. Next slide. Next slide. Now, genetic. The stem cells. The stem cells are progenic cells, biological cells, multipotent cells. It can primitive cells, and it can produce all types of body cells when it is adequately implanted. And two types of stem cells are available: embryonic stem cells and adult stem cells. Embryonic stem cells are available in the umbilical cord of the blood, and stem cells, progenitor cells, act as a repair system for the body, and it is the strategy was used in many conditions. Adult stem cells are frequently used in medical therapies. Bone marrow transplantation is the root of stem cell implantation. Next slide, please. My throat is not all right. Some people are, that is, next slide, please. So this is previous slide. Next. Yes, the virus. So this is the HIV virus. It needs to enter into the cell. It needs two receptors. One is CD4 receptors, another is a core receptor CCR5. The CD4 receptor is universally present, and through which only it can attach. And this is also attaching to the CCR5. Two receptors put together, and it removes the coat and the viral core enters into the body. Certain individuals are devoid of CCR5 core receptors, so they are naturally immune to this infection. So normally 1% of Caucasian population are devoid of these CCR5 core receptors. If you found out them and took their stem cells, and these stem cells that is introduced into bone marrow transplantation into the other people, then the people will develop new cells without CCR5. So they may be immune to this infection. This is the principle of stem cell transplantation. Next slide, please. Next slide. Yes. So I told already the Caucasian population 1% were divide of this delta 32 deletion of the CCR5 receptor. So they'll naturally immune to the HIV infection. Next slide. But it is very hard enough to get the good compatible because 1% population, Caucasian population. In other population, we don't know what is the prevalence. In African population, it is 0%, and very difficult to get a donor. Next slide. So there is a one case first reported to be cured completely is Timothy Ray Brown, and he is HIV positive American living in Germany, had leukemia and also HIV positive. He was taking undergoing chemotherapy, and he received the transplant stem cells and supposed to be totally cured. Next slide, please. But it was very after very long struggle only he was able to get the donor. Nearly 70 donors analyzed, and he get and the first donation was failed. So next donation will be was benefited. By this donation, he was cured by both from leukemia and also from the HIV. Next slide, please. Next slide. So the Anthony Fauci is one of the pioneer in HIV studies, telling it is very very difficult, it's impractical, like that they were telling, painful and also impractical. Next slide, please. Next, yes, it's a painful and complicated, expensive. So all these things are there. Next slide. So the patient is trading one poison from another. So he may be receiving that donor got the implanted, but he has to receive immunosuppressant drugs to prolong the donor, that is a recipient. As a recipient, he has to receive a immune suppressant drugs for lifelong. So that is also another poison. So that is also there. So present condition, the patient remains off from antiviral drug, normal CD4 cell count, and he was submitted himself for various studies, and his cells, all the cells were studied. Only two times it came as positive, but it was not enough to produce any infection. Next, next slide. Another genetic engineering is there is a zinc finger nuclease. It's an enzyme eliminating CCR5 expression over the CD4 cells. That can eliminate that genetic engineering. We can use the drug, and we can eliminate the CCR5 co-receptor from the people. So that the new infection, new cells cannot be infected. So there is another thing. And safe, and they have modified the half-life cells for 48 weeks, but expensive and difficult to scale upwards. Next, gene therapy. So there is another thing called as editing out certain genes from the HIV that help it get into the other cells. You would still have the virus in your body, but it could not infect you or others. So that is the thing. It cannot have that the virus cannot infect others, cannot infect a new cell. Adding protective genes like the ones elite controls are born with. Some people are having, we have demonstrated elite control, so they never received the drug, and in spite of that, they have suppressed the virus, and immune system function normal. So likewise, it protects the protective genes in the, it modify the HIV, it will remain dormant inside the body. So that is the renovating the genes from HIV that have become part of the cells infected with virus. This uses technology such as CRISPR that can target the HIV genes without harming the infective cells. So that is CRISPR. That is a newer chemical. Next, genetic material. Advanced gene therapy. There are researchers significantly reduce the HIV levels in mice with the genetic therapy induces immune cells to fight better against the virus. Publishing these reports, there is molecular therapy that was appeared in the reference down. So it's called as that is chimeric antigen receptor and inserted into the gene for the molecule and into the blood forming stem cells and the newer cells produced are immune to the infection. That is chimeric antigen receptor inhibitor are available, and these two part of the it acts in two parts. That is recognizes the antigen and in case instruct the immune cells to locate the and kill the HIV infected cells. So blood forming stem cells give rise to all kinds of blood cells, including the immune cells. So it is that is it recognizes the antigen and prevents the antibody production, then also kill the infected cells. So this chimeric antigen receptor carrying blood cell stem cells give rise to functional immune cells and also could kill the HIV in the mice. Consequently, mice experience an 80 to 95% drop in the viral load. The researchers concluded that such a genetic therapy may be feasible in HIV positive humans. They also believe that therapeutic techniques may be used to fight other diseases also. Next slide, please. Kick and kill method. So this is a easy, little easy, not a very complicated one. So this is a that is there is some drugs called as HDAC, that is histamine histone, that is histone deacetylase receptor inhibitors. These list. So this what is this doing? So it will enter into the circulation and find the um, reservoir cells and flush the HIV virus into the circulation. In the circulation, we are already having the antiretroviral drugs that will extinguish the virus. So it's simply kick and kill. It is kicking the viruses out of the reservoir into the circulation. In the circulation, ART will take care. So that is the thing. Flush this CD4 HIV infected with the drugs. Varina, that is this HDA, these inhibitors are available in the market also. That is orinostat, panobianostat. So these are some drugs are available. Make susceptible for ART expressed out of the these reservoirs. So it will eliminate the virus from the reservoir into the circulation. In the circulation, the antiviral drug will take care. Next slide, please. So Orinostat is a drug which is already used. It is named as Solinsa, and it is used as a used for it is a FDA approved drug for cutaneous T cell lymphoma. Cutaneous T cell lymphoma. So that drug, when we are giving as a next slide, please, is a 400 milligram statum dose. It will eliminate the virus from the reservoir into the circulation. In the circulation, it is taken care by the antiretroviral drugs. Next slide, please. Hello, next slide. Yes, the dose is 400 ml statum. They tried flush. Next slide, please. Some other drugs are also on the pipeline. So these are the GS9620 TLR7 agonist phase 1 safe trial started in human beings. Study in primates are successful. Protein kinase C antagonist by bryostatin. So these are the that is called as LRA, latency reversing agency. It will reverse the latency similar to HDA. See, next. Keeping latent virus HIV dormant may lead to functional cure. So this is one thing. Previously we saw the virus has been flushed into the circulation. So this is what is this. So this makes the latent cell or dormant virus in the latency in the reservoir forever in the dormant stage. It will never come outside. It will never replicate. So it will remain as a dormant forever. So that is a thing. So there is also that is also possible. That is a one drug called as cortistatin A is isolated from the marine sponge known as Corticum simplex. It has been shown to inhibit TAT of a viral protein and instrumental in prompting the virus to replicate. This study shows that the compound reduces the viral reactivation an average of 92.3%. So this is also possible. So it made the reservoir ever as a dormant stage. It will never become an active virus at all. So that is the aim. So that is cortistatin derived from a marine sponge. Next slide, please. Immune-based therapeutic vaccination. Vaccine is available. Therapeutic vaccine. So that's also under trial. They are trying. That is, it is well effective in a simian virus infection. So a CME is a CME virus vector containing simian immunovirus GAG, reverse, TAT, and NEF envelope and pole inserts lead to the viral control of the pathogenic simian virus infection in a subset of primates. So that virus also, that the vaccination also in future may be useful. The virus in the reservoir decreased over time. The results indicate vaccine contribute to viral clearance. So therapeutic vaccination. So that is also possible. Next, next slide, please. So another thing is hit hard, hit early. So this is next slide. Next slide, please. Early treatment. Early treatment means so before the latent reservoir established inside the body, we start the treatment. So before establishing the latent reservoir, we eliminate the virus. So there will not be any latent reservoir at all. So that's also they have tried, but I will give an example. Hit caught the with ART before the latent reservoir form. That is a treatment treatment should be started as early as possible during the primary HIV infection, that is acute infection and stage even prior to that. So that is the idea. Next slide, please. But it is a problem is diagnosing at this stage is very very problematic. Next, so this called as Mississippi baby. The mother was identified as HIV positive till labor started, and if she was not identified as HIV positive till labor started, not coming for any follow-up, the antenatal follow-up. So no, not on ART, and confirmed the presence of HIV DNA particles in the baby also, even the in utero. So the ART started within 30 hours after birth for the baby. So after the mother also was treated. So after 18 months, the baby missed from the follow-up. After 2 years, she once again appeared and came for the follow-up. Surprisingly, the viral load undetectable in spite of the baby was off from the ART for more than 2 years. The ART withheld under continuous and vigilance, but unfortunately, after that virus relapsed after 3 years. But this is also possible when the baby is not missing and the treatment was continuing. The baby could have cured completely. Next slide. So the ray of hope, apart from these various trials on HIV cure, are going to be on with various drugs and compounds, also for therapeutic vaccination at various centers of the world. A total cure to AIDS is not far away. Within reasonable time, possibly within another 10 years, we may likely to achieve. Next slide. Next slide. Already, 6 cases of total cure from HIV had been documented so far. 4 were recipients of stem cell therapy. I told about Timothy Brown, and other some cases also had been cured, and two other cases spontaneous cure. The spontaneous cure is number one is San Francisco patient Lauren Willenberg. I told about the elite control. I have a case in my practice. One man who is having HIV virus, HIV infection for more than 21 years, 22 years, not started ART drugs at all, but his CD4 count remains more than 1000 till now, and but unfortunately his viral load also little more than 10,000. So it is called as viremic control. But here this elite control is totally virus will be zero, undetectable at all, without any drugs. So that is called as elite control. So some people, so these San Francisco people, that is Lauren Willenberg, who was first person believed to have naturally cleared her HIV infection. The virus in elite control is more likely to be found in gene deserts, and where the HIV remains tightly locked down, unable to replicate, and that Willenberg case known as extraordinary elite control. No intact virus were found at all. Next slide, please. Similarly, another patient is called as Esperanza patient. She is from Argentina. She is also a lady, and this Esperanza patient, after that, this Esperanza is the place where she was hailing from. So the patient was called as Esperanza patient. Appears to be a new case of spontaneous cure few years back, and that 30-year-old woman was first diagnosed with HIV 2013 and gave birth to a HIV negative child in March 2020, and researchers report the exhaustive search of 1.5 billion of the woman's cell failed to turn up a single intact capable of virus replicating. Fittingly, the Esperanza means hope in Argentina, Spanish. So this groundbreaking study of elite control, the small group of people who can control the HIV without medications, was included by the Journal of Science in 2020. Next slide, please. Elite control are HIV-1 positive subjects who control the virus replication without antiviral therapy. The subsets are, I told about, that is a viremic controller. In that, the patient never had any symptom for 21 years, and his CD4 count was remaining more above 1000 cells. Next slide, please. Next slide, please. Mechanisms of this elite control is defective HIV-1 variants could be spontaneous cure, innate resistance of HIV-1 infections by birth, limited availability of susceptible CD4 T cell target to get infected by the virus, and an immune based control of viral replication. So naturally, some like CD4 T8 cells, the T is not CD4, CD8 cells, they are killer cells. Some cells are identifying the infected viral cells and eliminate it. So that's also possible. So these are the possible mechanisms people are thinking, not yet to be proved. Next slide, please. So, thank you very much for your patient hearing. So, we are marching towards a cure. Very soon, we will reach that cure, and it will be a boon to everyone who are millions of people have been infected throughout the world. Millions of people are on ART, so they will be all benefited. Thank you very much for your patient listening. Thank you very much.
Thank you so much, sir. Thank you for your valuable time and for such an energetic talk that you have shared on our platform with all our viewers and making them understand about HIV cure, how important it is. Thank you so much for that. We have received few questions from the participants. So with all your due permission, I would like to put across those questions to you.
Can you
So
focus
the
in?
first, yeah, am I audible?
Yes, audible. If it is focusing, I'll be reading very well. Okay, tell me.
Yeah, so the first question is related to how do combination approaches such as combining latency reversing agents with immunotherapies or gene editing contribute to HIV cure research?
Gene editing and gene therapy are that I told about cortistatin and other drugs that is uh, CAR, that is all these things, chimeric antigen receptor. So these are the things which is chimeric antigen implanted in the stem cells and converted. And the cortistatin also we can inject something like that. So they are under research. There is a genetic engineering is a recent advances, but I cannot tell about that more because I'm not an expert in the genetic engineering.
Thank you so much, sir. Thank you for answering that question. Other question is what are the difference between shock and kill and lock approaches to HIV cure, and how do they target the viral reservoirs?
So both are same. That is shock and kill and kick and kill. Both are same. That is elimination of the viral reservoir. That is the virus is flushed out from the reservoir into the circulation, and when we are giving the potent antiretroviral drug, highly active antiviral drug, and it will take care of that. So that drugs, that is a orinostat and panbiostat, all the some other drugs are also on the pipeline. So they may be fully effective and can identify all the virus and eliminate the virus from the reservoir and make it susceptible for the our antiretroviral drug. Thereby, we can achieve a sterilized cure.
Thank you so much, sir. Thank you for answering that question and the other question. That was the last question for today's session. And I would like to thank all our viewers for their ardent participation that they have shown by staying tuned with us throughout the session. And I would like to thank you, sir, for taking out your valuable time and for being here at our platform and sharing such wonderful insights with us and for answering the questions and queries of our viewers, whatever they has asked. So thank you so much, sir. With all your last comment, we can conclude the session here for today.
I am sorry. My initially I am not able to load my slides on thing, and my throat is also was not cooperating with me, so I'm not be able to. I'm having some hiccups. Otherwise, thank you very much, and we all hope for the HIV cure, the best cure, and we'll achieve the soon, and it will be a boon to humankind. Thank you very much.
Thank you so much, sir. Thank you for your valuable comments, sir.